Oh,
Okay.
Hey,
We're on.
sound. We're good? Excellent.
Yeah.
Perfect.
Well, hello, everybody. We're here to talk to you about Kiwi and about, very specifically, how we got it into other projects, namely Fedora and CentOS.
Yep. So, let's see, we're ready to start. So a little bit about ourselves. I have been around doing stuff in the community for a long time. I think it's now been at least 10 years for openSUSE, longer for some others. So do stuff in Fedora, Magia, openSUSE, CentOS, Alma, whatever. I do a lot of stuff at the base layer and in desktop Linux. And I have my own company, Velocity Limitless, where I'm basically an open source mercenary. If you want to look that up, that'd be fun. But I also do a podcast about the business of open source called Pseudo Show. And you can look it up. I think it's a fun show.
I'm David Duncan. I'm a partner solutions architect at Amazon, and I spend my time working on community projects that help to support the Linux community and specifically the enterprise Linux partners on Amazon, which leads me to get into a lot of trouble with Neal, especially around...
Not really.
Well, not really.
You're fine.
Yeah, but we spend a lot of time together working on harder projects that are related to deployment and configuration of images and instances and providing support for the various community projects that we think are important.
Yeah, so we're talking here about, red kiwi fruit and stuff, but let's talk about the beginning. The beginning is a little blue because way back in the day when I was working at, this company here, Datto, I brought Kiwi to it doing image builds because we had a terrible image building story. I'm not going to go deep into it because, hey, I gave a talk at an openSUSE conference about this. You can go check it out. The title's right there on the picture. So, if you want to go check that out and hear it, you can find out more about that. But the long and short of it is, we adopted Kiwi to use this, and as part of doing that work, I got involved in the upstream Kiwi development and became essentially an independent developer of Kiwi, specifically to bring support for non-SUSE platforms and to improve that. And as a consequence of that, we were able to make Kiwi essentially something that is a cross-platform production-ready environment within Datto. And that breadth of builds and ease of modifications and some of the other features that we did made it so that it was a very approachable platform for people to be able to take control of their operating system environments and the customizations that they wanted to make.
Yeah, I put a lot of clarity into it for a lot of different builders, and very specifically, hit that next slide. Very specifically, we started to work on it from the perspective of how we could build images on Amazon. And so from that perspective, I was working with the SUSE team, and of course, Kiwi was an integral part of how the images were being built at SUSE. And that was the promise there was that we could do a better job of building more than just the SUSE images when we started off this project.
Right. This
project being the one that came after this.
So this project is actually, Kiwi doesn't enter the story yet, and that's important because this project was, okay, we want to have our Fedora cloud images be able to boot on UEFI and BIOS, because up until the point of this, which was in 2021,
right?
Don't ignore the relative dates thing. The relative date computation is weird on computers. But this was like 2021, early 22, that we were doing this, and this was for Fedora Linux 33? Yes. No, 35. So we were doing this in Fedora 35, and the idea was, okay, well, we already have this that are building for BIOS. Amazon now supports UEFI. We want to get everybody onto the UEFI train because our lives are miserable trying to debug 3 different ways that everybody boots everything. And yes, I said 3. I know that there's only 2 methods we're talking about here. That comes in later. And it turns out this is hard. And the imaging tool that we were using was called Image Factory. It uses a companion tool called Oz that automates installations. And then it uses the automated installations to create a disk. And then it tweaks the disk so it can boot in virtualized environments, including public clouds. At the point that we were starting to work on this, Image Factory was already kind of dead-ish. The guy that was working on it was reassigned to go do other things, and there wasn't really anything going on. And like I think the most recent thing that I had even tried to work on it was trying to port it to Python 3. That tells you how old it is.
Well, it was it was 2.7 when we retired it.
Yeah, and so then you see this list of things in the middle where you see me and David and working on writing these commits and stuff. So this is because the tool didn't work outside of Fedora infrastructure. If you tried to boot it up anywhere else, it would just crash. And so we were stuck in this situation where, like, okay, the only way I can actually iterate on this was go ask a helpful, nice Fedora Relinch guy and say, hey, Mr. Relinch guy, could you like take my commit? I don't know if it works yet. Let me merge it. And then can you please build it and tell me whether it boots or not? And this happened a lot. And I think this was over the span of like, I don't know, 2 weeks. And I basically hated my life trying to implement this change because the tool was incoherent. I couldn't do anything locally. I couldn't qualify anything. And I had to wait and loop and wait and loop. And you know,
Hours, countless hours.
Countless hours. And David and I tried, we got so frustrated, we actually tried to fix said tool that is, you know, not living, to make it run on an AWS instance so that I could like do the loop faster. No, we never succeeded at that. At the point, we gave up after like a week of trying and went back to the loop. And I said 3 build processes because at the very end, I realized I broke PowerPC. And so I had to go figure out how to fix PowerPC. So there's the prep partition for Power.
Number 3.
I said 3 processes.
Yeah, that's right.
So that's why. So this was the genesis of David and I going and saying, this is an unsustainable mechanism. This process, frankly, sucks.
There has to be a better way.
There has to be a better way to do all this stuff. And like, oh, people were talking about, oh, we could use Packer. We could do this. Well, Packer requires an image to already exist first. We're making the image first. And, sorry, what? Oh, that doesn't exist yet.
That didn't exist yet. Yeah, that's right.
That didn't exist yet. Don't worry about it. We'll get there. We'll get there. So the person in the audience was shouting about Red Hat Image Builder. It doesn't exist yet. This is 2021, not 2023. Anyway, so we go on with this. And so then the beginning. In 2021, also, I was simultaneously bootstrapping the Fedora Sahi remix. And because I already knew Kiwi and I was working at Datto still, we were doing all this stuff in there. I was like, okay, well, I'll take the pattern that I made at Datto and pull it out and reuse it for being able to make the descriptions for creating Fedora Sahi remix, which my other computer, not this one, my other computer is actually using that. And yeah, so we made the Fedora Sahi Kiwi descriptions, and those were used to create the Fedora Sahi remix. And that was actually the first instance on the Fedora side of Kiwi being used. Not the second, the first. Yeah. And then from there, after we understood the process of how to make images that actually work, David and I made this proposal to build the Fedora Cloud Edition images with using Kiwi and Koji. This is, we'll get to this a little bit more in depth, but like during the time frame between the first screenshot on the left and the second screenshot on the right, we got some work done to get Koji support implemented. We'll get to that in a minute.
I think that was another thing that's worth mentioning is that we already knew this was our goal when we resurrected the Cloud Edition. So we had gone through the process of resurrecting the Cloud Edition using the older tools in order to not make any waves around the structure of the project, because we didn't want to contradict anyone who might be in the middle of trying to start, people who were using the older technology in the downstream community. We didn't want them to have a problem with what we were doing here. But we knew this was the direction we were going because it worked.
Yes.
And it was working for us in so many other places.
Right.
So then this is what showed up.
Right, and so when we were making the change proposal, we were talking about this and what was the strengths around doing this. I mean, for us, it was making it approachable for people to take what we're making and layer on top of it with their own content, with their own designs, their own customizations. And, you know, the fact that it's easy to run in different environments because, you know, it's a tool that someone has actually figured out how it's supposed to work and written it down. You'd be amazed how many tools don't do that part. And so everything's written down. It's super easy to understand how to interact with it. Being multi-distro and me being experienced with the code base and actually personally for years building up the non-SUSE distribution support, specifically with Fedora and Ubuntu, and doing, with the advanced bootloader integration and having the schema to be like, hey, you just put together sets of options that don't make sense. You have any idea how many people will actually just put options together that don't make sense and the thing happily just does it? And then you come out on the other end with something that doesn't make sense? You'd think that that would be obvious, that if it doesn't make sense, it would stop somewhere, but no, lots of things just don't do that. They'll just happily do the incompatible setup, and then you have a broken image, and you don't know until you've wasted 2 hours of your day waiting for it to build.
And we knew we were going to get a lot of friction when we started this, so we had to have, good talking points. We really understood that what made this a good project was that we could complete a lot of the work that everyone wanted to see done, and that work was not as easily executed with the tools that were in front of us that were available, right? Or the tools that were evolving, right? At the same time, Welder was there as an interface to the
Lorax.
Yeah, to the Lorax, and people were trying to make that run, but it wasn't running. Mm-hmm. And that was the thing, is that there was an excitement around how this was going to integrate into the Jenkins, and we were going to be off to the races, and yet that went as well as most all of the other Jenkins projects that I've been involved with. So.
Yeah, even with doing all that and having all those benefits, it wasn't just smooth sailing. There was actually a lot of work that had to be done on top of it. So this is a project board that me as upstream Kiwi developer made when we first started doing the Fedora adoption thing. And this, we've done 39 separate, Kanban board tasks, which evolved into like tickets and pull requests and whatever. And there's still stuff on this list for sure. But we have done so many things in service of bringing it to Fedora and the Red Hat platforms. Some of the things you might be familiar with that in Switzerland that you are benefiting from. For example, bootloader spec support was actually originally introduced because Fedora used bootloader spec since Fedora 28. And we also had stuff around improving the disk definitions for being able to support things declaratively, especially for weird ARM platforms and boards and stuff like that, whereas previously you had to, basically shell out and mutate the disk through a shell script. We can now do things like set whether it's GPT or MBR, set the disk layout, set the label IDs for different partitions and such. Lots of these things that used to be imperative are now declarative. We have support for multi-arch EFI because that's a thing that Fedora does. You can have your 64-bit EFI, your 64-bit images can also boot from 32-bit EFI to 64-bit operating systems. There's filter now for being able to make sure that you can constrain how much content goes into the embedded ISO ESP. There's things around enhancing includes, excludes filters, the ability to have description fragments and actually include them in a logical setup so that instead of having one big XML file or YAML file or whatever, you could have a top-level file that includes a bunch of other ones, and then it composes them into a unified description. That was created specifically because in the Fedora world, we use that model of horizontal composition to produce our descriptions with all of our older tooling, and we wanted to keep that workflow going forward. And within the SUSE world, this just wasn't a thing because everybody just forked their own descriptions, dumped it in OBS, and forgot that they existed. This was not a model we wanted to replicate in Fedora, so we made a lot of effort to add this functionality that people wanted. So there was a lot of improvements that came in from Fedora requirements that I think also will benefit and have benefited the SUSE platforms as well, and other people too.
Yeah, there's a variance markdown file in the Kiwi descriptions that Neal has carefully hand curated that kind of goes over all of the configurations that we have for Fedora today, and that shows the relationship in between the compositions and the platforms.
Right.
Also, I just want to point out, shout out to our mainframe group over here that we've got the S390 support.
Oh yes, yeah. Oh, poor Marcus, man. Right. So going back to this a second, one of the things that's obviously cut off on this, because this is not a complete screenshot of the board, was when going through Fedora Cloud, David, myself, and Marcus went into this three-way loop of figuring out how bad S390 boot processes are. and making everything work with, in Fedora, we don't use grubemu wrapped around ZIPL. We use ZIPL directly to boot in bootloader spec mode. So we restored ZIPL support, we added bootloader spec support, and then we had to figure out that we didn't do it right, and then we figured out that even when we did it right, it wasn't quite right anyway. And we went through this process of getting S390X to work properly, and now we have GPT support on IBM Z, because now that's the thing that we needed to do. So yeah, like it was a very tumultuous ride getting Fedora Cloud images working well on Z systems. And that was not a thing that we were even doing before.
Right, it's just a requirement.
So now that was just Kiwi, but we actually did more things. So this is on the left is all the changes that were done to Koji, the build system, to add the Kiwi plugin so that we have native support for building images using Kiwi using the Koji build system. So anybody who uses the Koji build system to do their own packages, their own distributions and images, whatever, like they're now for free-ish able to do image builds with Kiwi instead of using anything else. And this is now in use in Fedora, and I'll talk about in a minute about CentOS, as well as a number of third parties and a bunch of people in the community who run their own systems. Like I know CERN runs their own Koji, and I believe they've actually started experimenting with using Kiwi for their image builds. And there's a few other companies here and there that I'm aware of that have reached out and asked about stuff.
Awesome.
Yeah, and then on the right, this is Punji. So most of y'all don't know anything about, I'm going to assume most of y'all don't know anything about how the Fedora release engineering tooling works. We have the snake charmer, Punji, that automates and orchestrates the run of the compose process through Anaconda and all the other things. Originally, because Anaconda was the thing that made the composes, it was called Punji, the snake charmer that automated Anaconda. Now it actually doesn't run Anaconda at all, so it's kind of a weird name, but hey, there you go. But this is essentially the single big tool that does all the things that the pile of scripts that we have in the openSUSE release tools repo has. And so we added orchestration support for the Kiwi build command from Koji, as well as setting up all the variants and handling the metadata. Product MD, which is their way of handling what are the images associated with and how do they get published. All this stuff in here. That was all done, and it allowed us to be able to say we can go from a definition that describes what a Fedora release creates to have what are the repos and the artifacts, and then it can go from that to use Kiwi to produce it and then send it off to the right places to be published. Like containers go to the Quay.io registry, right. And the WSL image goes to, actually, I don't think it really goes anywhere. It just gets published to the Mirror Network. Yeah, it just gets published to the Mirror Network now. Yeah, and then the FEX thing that we do for x86 simulation on ARM, that just, I think, also gets published. Oh, it gets published back in as an RPM because we have to do twisted things for that. Well, at this point, so I want to say that at this point, this became interesting to the QA team, right? Now, right. We have images that are being built. And there was kind of a windfall that occurs as a result of where we are now, and I think that might be the next slide. But at this point, once we had all of this put together, the next thing that Neal did that was very interesting and super important was he started throwing test framework validations at the Kiwi description. So the reasons that was such a valuable thing is because previously we had kickstarts and there was no validation for the kickstarts. The kickstarts themselves just ran and failed, or ran and worked, or maybe both. Or maybe both, and there was no real artifact or no real log that would tell you that you had or had not gotten exactly what you wanted. So in this case, though, we're using Kiwi. So with the test framework validating the profiles, then we ended up with the ability to push this all through, and then we received back an artifact that included the packages, an artifact that identifies all of the components that are in the image as a result of what we had created. And so now we knew we were going to get a good build. Once we got that build, we would get a package manifest and all of the things that were expected. And that was something that had never happened before in the context of Fedora. Of our images, our deliverables. Exactly. The other key thing was, all this thing about having this testing and having these outputs and information, people can now send changes to the descriptions. And before we even merge them, they get a test artifact that they can try out on their own. They can experiment and see things, or they can fork it and put it in their own space and do their own thing. And that's fine. It's great. Because our testing infrastructure is virtual machine-based rather than container-based, we don't have the same restrictions that say, like if you try to run this in GitHub Actions where you don't have loop devices, or GitLab CI where you don't have access to loop devices, you don't have access to privilege mode, so you can't mount the correct things to do stuff. So these were real virtual machine-based environments. The CI was structured in such a way that it was optimal and fast. So in 30 minutes, you have essentially a complete compose of the artifacts that are release blocking, and you can test to see whether any of them are good or not based on your change. And if your change is particularly global, this is important. And this was useful when, during Fedora 42, I changed the live images from using SquashFS to using EroFS. And so the change to EroFS was able to be staged, and we could check it out and see whether it was meeting our parameters for good quality, whether it's on build time and compression and all this other stuff. And we were able to stage that ahead of time. And again, this was also adding features to Kiwi. Kiwi did not have the ability to make live images that used EroFS instead of SquashFS before this. We went and did that part too. So all these things happened, and this gives us the ability to support the community in being able to make their own deliverables, leveraging our framework in a way that's maintainable and sustainable, because we have distributed ownership of these descriptions. The different teams that make their own artifacts and their deliverables, like for example, me from the Fedora KDE SIG and the Personal Systems Working Group, we maintain the Fedora KDE Plasma Desktop Edition, as well as the Fedora KDE Plasma Mobile Spin. Well, those artifacts are owned by those teams, and they want to be able to maintain them and update them and so on, and they in fact can. Same for Workstation with the GNOME and the Fedora Workstation images, and so on and so forth.
But they came from everywhere. As soon as this was functional and started to work for the cloud edition, even before we'd worked out all the metadata for Punji, we had
people were interested.
Yeah, we had a list of groups who were looking for a way to automate their systems and their build systems to make them consistent with each one of the compose IDs that came with each, that ultimately became a release.
Yep, exactly. So while this was all going on with Fedora, we were also doing stuff in CentOS as well.
That's right.
So I am the co-chair of the CentOS Hyperscale SIG, along with my friend and colleague, David Kalvika, who's not here. But yeah, we have this Hyperscale SIG, and we had gone through already CentOS Stream 8, where I was using the old tooling with kickstarts and all that other fun stuff that David already talked about why that was sucky. So this time around with CentOS Stream 9, this was 2021, 2022, mostly 2022, we decided we were going to try to do things a little differently. So I started with using Kiwi, and we worked with the Koji people to make sure that we have this plugin, as I mentioned earlier, and we saw the commits and the pull requests for enabling the Kiwi plugin to be functional. Well, we turned it on for Hyperscale in the CentOS Community Build Service, again, another Koji instance, so that we were able to start using it for CentOS Hyperscale images. And so CentOS Hyperscale was the first CentOS community group that started using Kiwi, and we used it to build our cloud images, container image, and we haven't yet we just started doing the container image. We started with cloud images, then we built our live workstation images with the CentOS Hyperscale KDE desktop, and then we kind of expanded beyond that. And right now, we're also on CentOS Stream 10 now, where we started from the very beginning with this, and it made it very, very fast for us to identify flaws and fix things, and then get up to a point where we now have production quality images that people can use to leverage our technology. And this was so good that another SIG decided to, on their own, adopt this technology. So Troy Dawson, who's an awesome dude in the Fedora and CentOS community, he does lots of good stuff, and most importantly, he's my bud that makes KDE work on the enterprise Linux platforms, because KDE is the best, and it needs to be available everywhere. And so Troy created the CentOS alternative image SIG to provide light images and things like that, other platforms and product support that the core CentOS stream, the Red Hat team, doesn't want to provide. And he chose to use Kiwi based on the work that we did on CentOS Hyperscale on his own. and he loves it. Like he told me it was his, like just the other day, he told me it was his favorite tool ever, and which is wild.
Yeah, we had that talk.
Yeah.
So one of the things to remember here is that each one of so the hyperscale also includes repositories that are foreign to the standard CentOS builds.
Right.
So for as far as this all in fact was happening at the time that the big CentOS stream changes were being made.
Right.
And so there were some growing pains, and Neal carefully avoided a lot of the growing pains around the build process by building the images that we needed for the hyperscale space in the Kiwi environment, which made it a lot easier for us to deliver on what it was that was necessary for production. So,
yeah, and Troy saw what we were doing because I gave talks at the CentOS Connect about what we were doing. He was very impressed and was interested in doing this, and I taught him a little bit about how to do this, but then he managed to figure out a lot of it on his own, which is great. That shows that Kiwi is approachable and awesome. And through that, he made live images, and I think he's working on ARM images, and he also made the Red Hat community's first set of WSL images, because the alternative image sig made WSL images that you could then install into your Windows system using Kiwi for CentOS Stream 9 and CentOS Stream 10. And the work that was done there was actually then pulled back into Fedora by
That's
David
right.
and Justin, Jeremy Klein.
Jeremy Klein.
From Microsoft to actually then bring this back into Fedora and make it more official. And yeah, and that's now fed again from Fedora back into CentOS to go out into RHEL at some point is going to, like some of the infrastructure that we created will be released as part of RHEL in the near future, so that it'll just be super easy to pick up and make your own WSL images, which is I think kind of the goal that Red Hat's going with for the WSL stuff. So the end result was that using Kiwi with CentOS allowed unifying all of the different practices, and it's not just CentOS, it's also with Fedora, but it allowed unifying the way that we approached providing deliverables in the CentOS community on top of whatever Red Hat was providing for CentOS Stream Core across whatever Forge environment we were using, across whatever tooling we would like to use, across whatever mechanism of development we'd like, and it enabled for the first time a reasonable process for the community to build add-on layered products and spins and whatever on top of CentOS Stream, not just for hyperscale where we have modified stuff where we restore Btrfs support and we do awesome things with RPM cow and things like that, but even if you want to just take CentOS Stream and EPEL and then have a KDE desktop because KDE is the best, you can do that.
Well, about 2018 there was an acquisition that people may remember from the Red Hat side that actually started to split out a certain amount of the core concepts around how cloud native would be approached, and part of that ended up delivering a core component of the core. That's a good statement there. Around the container-based workloads from GitHub, and as a result of their workflow being delivered consistently and exclusively through a GitHub workflow,
on private infrastructure.
On private infrastructure, it did not really fit with it still isn't really maintained in a way that we think is consistent with the Fedora mission. And so one of our goals was to provide a methodology for us to unify regardless of where they were actually doing their development.
Yeah, and I think we can solidly say that Kiwi is not just an openSUSE tool. It is a community Linux tool. It's 100%. A great one at that.
Yeah.
So, and now, roughly half of all Fedora artifacts are built with Kiwi, with more coming over time. In fact, I didn't put it in here because I forgot until just now, but Fedora RISC-V, that new architecture bring up, all the images were produced from the very beginning using Kiwi because it was stupid easy to just take what we already had and just run it for the RISC-V architecture. All the CentOS community images are built using Kiwi. As I iterated earlier, this is kind of the thing that we're doing. And it is now an option that people are adopting en masse within the Red Hat ecosystem of derivatives. So like, we'll see things like the various immutable desktops are considering leveraging Kiwi for building their stuff. There are new derivatives that are like, well, we want to take different approaches to how we want to produce this, but Kiwi makes it easy for us to make this, and things like that. So, we've managed to create a tool that creates a connection going from upstream to midpoint to downstream, regardless of where you start, whether it's from the Kiwi project or Fedora to CentOS stream and down. It's happening all over.
Yeah, and then we can, just from the commercial perspective, we can leverage this to push right into the build infrastructure for all the public clouds. Right,
and like what we've been doing now at this, I guess, the winning state. Are we winning? We are, I think. At this point, the kickstarts are slowly being erased, retired, whatever. The container builds and all of the base images, some of the all net new image content has been produced with Kiwi. QA processes that used to that produced images ad hoc now use Kiwi as well. For example, the Fedora kernel test day for 6.14 and 6.15 used images produced from Kiwi using just a single modified manifest file that's called Fedora kernel test day. And Justin Forbes just runs it with a couple of extra options, and he just nests it inside of the Fedora Kiwi descriptions repo, and he can produce Fedora KDE and Fedora GNOME images that people can then try out and test a new kernel with, and that's used as part of the test weeks that we do for that. And Enterprise Linux Next adopted Kiwi, actually, I think it was like at the beginning of this year, was it?
No, it was at Rochester.
Yeah, oh my gosh. It was a year.
2024, it was a year ago.
Bloody hell. Yeah, so it was a year ago that the Fedora ELN group decided that they wanted to use Kiwi to produce the images because their other options were not in great shape, and we could produce everything relatively quickly. And so now I think they're producing cloud images. I think now they're producing a WSL image. And so it's super easy now. If you want to check out what RHEL 11 might look like at this point in time, you could go download a Fedora ELN image. And that was produced with Kiwi. So, questions?
Yeah. I'm going to take this back one slide and just say that this is my best Adam Williamson, who runs the QA group for Fedora, talking to Neal about Fedora Classroom.
Oh boy, really?
That is.
Fine.
It's the best one I can do.
So, when you're building for AWS to boot with EFI or BIOS, are you building two different images?
Nope. One image with all the toppings.
That's where we started. It literally is the first stages that we were in was trying to satisfy
Very nice that I'm not the only one who knows that the EFI image also boots happily with BIOS. So
Well, so originally, before we moved to Kiwi, and again, the start point of all this, is that we had two different images for UEFI and BIOS. And we were never uploading the UEFI image because constraints in the AWS system mean you can't actually upload two images of the same type with the same name into the same area. So they have to be one image. So that's why we had to work on merging those back into one image. And then all the other platforms were like, hey, we don't want you making BIOS images anymore. Please make UEFI ones. And then the other ones were like, we don't want the UEFI ones. Please make BIOS ones. And I'm like, I'm not making like 50 bajillion different versions for all of these things.
Yeah, and so our goal was to leverage what we knew about the EFI, and in fact, that was a series of hurdles. So it was not just a straightforward. It was not a straightforward request because not all the rules are strictly adhered to in every environment.
If anyone ever tells you that there is such thing as a good early boot process, they're liars.
Question in the back? That's Dan.
Yeah, he's going to roast us.
Maybe. So for the Fedora-based immutable images, we need to support RPM OS tree, and that's not yet in, right?
No, it's not. But the Corios team, as I like to call them, the Corios team is working on this thing in the CNCF space called bootc, and it's supposed to use OCI images combined with this AeroFS metadata thing where it's union mounted to create what is the facsimile of a real disk image, and that's how it's supposed to be the new immutable platform thingy. And in theory, that should be easier for us to support than RPMOS tree. I have yet to have enough time to finish digging into it to figure out like what the requirements are for,
so far the
bootc.
Yeah, so far the conversations have led us to believe that it's easier.
Okay, I thought it was using RPMOS tree under the hood anyway.
It is currently, but I believe the plan is to stop doing that eventually. And so the question that I still have is how soon is eventually?
We're encouraging it sooner.
We're hoping it's sooner.
Yeah.
Because I can futz around with OCI archives till the cows come home. That's not hard. Question is, what specialness of the OCI archives do we need to do to make them work? Don't know that yet.
So you're mentioning earlier that you were doing respins and all of that is super easy now with Kiwi, right? Because you don't have to go and copy all the descriptions. Last time I used Kiwi, the only mechanism I found was an include statement, which doesn't really do proper inheritance. Did you sort
Well, that was so the include statement is new. That was added for us. And Marcus and I basically compromised and was like, okay, we won't do full polymorphism. You'll just have one level in reverse inheritance. So we include the snippet and it merges back into the main document. For the context of how this works in Fedora, we use the includes to produce the snippets, and then we use profiles to create the inheritance model. So you have a profile that will require other profiles that require more profiles, and the result is essentially two levels of merging. You have a document level merge that happens from the includes, and then you have horizontal composition of all the components and the profiles to create the final definition of an image. And so what that does is it makes it straightforward for someone to say, okay, I want to have my own snippet, or I want to have my own top-level file and connect some snippets or my own ones, or mix and match, and then it synthesizes a working result either based on you passing in command line options, because as you know, you can pass multiple profiles via the command line, and that will create the same kind of linkage, or you can define it in the XML, YAML, whatever, that lets you do the same kind of synthesis without having to define extra options. So that's how we do it in Fedora and CentOS. And I encourage other people to do it this way. Actually, there is a prototype in progress effort for moving the openSUSE cloud images to the community, and that set of definitions uses the same model that we use in Fedora. So we may actually start seeing that kind of approach being used in openSUSE more.
Yeah, and then like I said, go check out the variants file that Neal carefully curates in the Fedora Kiwi descriptions, so that you can see how that relationship works.
Thank you.
Hi there, thanks for the presentation. I was just thinking about replacing Packer with Kiwi, because I didn't know that using Kiwi is that easy. Do you know if it's possible to write your own provider integrations for Kiwi? So let's say for Hetzner or just another hyperscaler that's not supported yet by Kiwi?
So Kiwi doesn't care.
Yeah.
So as long as you can produce a disk, so from the Kiwi perspective, all the providers and stuff that you have to do with Packer, they don't matter. The only things that actually matter are you can configure it to tell it what type of disk format that the provider requires, and that you fill it up with the packages and configuration that's actually needed for it. So if you look at the Fedora Kiwi descriptions, or even the prototype openSUSE cloud ones, you will see that we have the different cloud providers, and they have essentially a cloud provider definition which describes their disk and package sets, but then they're nested on top of common packages that exist. So like you knit them together and then you get something you want. So for example, for Hetzner, it's a KVM-based environment. They will actually I think they take a raw disk image. So you take a raw disk image and you configure it with KVM stuff. You put the QEMU guest agent, and then you produce it, press it, upload it, and Hetzner takes it, and you're done. So essentially, what I would suggest would probably work out to be is like, okay, you would automate a Kiwi production process and then probably have some EDA or something to then turn around and connect it to then uploading it to the right place, and then you use Terraform to do the provisioning automatically.
Yeah, from the SUSE perspective, we have MASH, right? And MASH allows you to do all of the
MASH is where you would want to define your upload providers.
Yeah, so moving to the provider is actually there. We built an entirely different thing. Actually, Jeremy Klein on the Fedora side built an image
Ansible based one.
Well, it was Ansible based, but it's an API based one.
Yeah, sure.
It's like, well, it's because
it's complicated.
Yeah,
yes.
yeah, because not all clouds work the same.
Yeah,
That's what I'll say about that.
Feel free to reach out to us, and we can talk about that other tool if you're interested in that as well. But if you've got your own workflow for uploading the things, you can slot Kiwi right in pretty easily.
Yeah, and I have opinions.
Thank you.
Okay.
Any other questions? Okay.
We really appreciate you spending time with us to talk about this. We think it's a great thing.